Recording in progress.
Hi students, in this lecture we are going to learn conservative force. Let us see what is it. If work done by a force is zero in a closed path, then that force is called conservative force. Definition is by a force work done is zero in a closed path, then that force is called conservative. Work done by conservative force is a path independent. And we can say examples: gravitational force, spring force, electrostatic force, constant force, etc. Okay. Let us see now in detail what is a conservative force and how to get work done by those forces. Right. Suppose we are taking a particle from A to B. Let us say it is the path is now like this from A to B. Now we are moving from B to A. So this is a closed path. So closed path means initial position and final position both are same. So here initial position is A, final position is also A. We have taken from A to B, then B to A. Okay. So in a closed path, the work done by a force is zero, then that force is called conservative. Okay. Right. Let us see now here what we can write from the definition part. Work done by that force from A to B plus work done by the same force from B to A equal to 0. This is definition, right? In a closed path, work done is 0. So from this, see what we can write. Work done by the conservative force from B to A is equal to negative of work done by conservative force from A to B. Right? Now let us do one thing. We are fixing the path from A to B, but from B to A, we are changing the path. I am repeating. We are fixing the path from A to B, but we are changing the path from B to A. Let us take now, this is a path 1. Okay. Now we are taking from B to A along a different path like this. Let us call this as a path 2. Okay. Or let us take a path is now like this. Let us call this as a path 3. Right. Now according to definition, work done by the force from A to B plus B to A equal to 0. Again, same logic from A to B and from B to A equal to 0. Next, B to A, it is equal to minus WAB. So from here, what we can say is we have fixed the path A to B. So this is a fixed, but we are changing the path from B to A, like along path 1, along path 2, along path 3. But in closed path, work must be 0. That means even though we are changing the path from B to A, work done by that force from B to A must be equal to negative of work done by that force from A to B. So from this what we can say is work done by conservative force must be path independent. Okay. Work done by conservative force must be path independent, right? Let us take one example for this. Suppose we are dropping a body of mass m from a height h. So we have to calculate work done by gravitational force. So block is moving down, gravitational force also downwards. Therefore, between force vector and displacement vector, angle is 0. That means work done is equal to, it is mg into h or into cos 0, right? Now, release the same block on an inclined plane. On an inclined plane. Suppose the angle is theta. Block released from top of the inclined plane and this is a height equal to h. Now we can see block slides down the incline. So we have to calculate when block reaches the ground, what is work done by gravitational force. So in this we can see between gravitational force and displacement vector, angle is not 0. In this, between gravitational force and displacement vector, angle is not 0. Displacement is along the inclined plane. So between these two angles now 90 minus theta. It is 90 minus theta. Then we have to write W equal to force mg, displacement along vertical. Displacement is along the inclined plane, right? Suppose its length equal to L, length of inclined plane, displacement is L. Okay, into cos of the angle. It is a cos 90 minus theta. Okay, that is now mg L sine theta. See, from this what we get? Mg into, in the place of L sine theta, it is equal to h. Means again it is same answer. So here it is moving along vertical. Here it is moving along inclined plane. Even the parts are different, work done is the same because gravitational force is a conservative force. Okay. Now the question is here, how to identify a given force is a conservative or not, right? Let us see carefully how to decide that. When we want to calculate work done by a force, definition is F bar dot ds bar, and this is equal to Fx I cap plus Fy j cap dot, in the place of ds bar, dx I cap plus dy j cap. Okay. Now simplify this. This becomes now Fx into dx, because I cap dot I cap, it is 1. Okay. Plus Fy into dy. Okay. Now focus carefully. If we can make this calculation, integration of this calculation without requirement of any other equations, then that force is called conservative force. I am repeating. If we can integrate now this one without the help of any other equations, then that force is said to be conservative force. Okay, let us take examples to get more clarity on what we have discussed. Suppose a force equal to force F bar equal to 2 I cap plus 3 J cap. Okay, then see in the place of Fx, we have tried 2. This is now 3, right? That means it is directly. So if I'm taking this one, W equal to integral 2 dx plus 3 dy. It is equal to 2x plus 3y. So to make this calculation, we do not require path equation. I am repeating. To make this calculation, we do not require path equation. That means for any path, work done by this force will be the same. Okay, that's why this force is now conservative force. Already we have discussed an example set: gravitational force, electrostatic force, spring force, constant force, etc. This is now constant force. So constant force is conservative force. Okay, let us take one more example. For example, force is xi cap plus yj cap. Okay, then see from this equation, let us call this as equation 1. From equation 1, see in that equation 1, what we have to write? In the place of fx, it is x. So x dx plus in the place of fy, it is y. Right. So y, sorry, it is y dy, right? It is y dy. It is y dy. See now to make this a calculation, it becomes x square by 2 plus y square by 2. So to make this a calculation, we do not require path equation. That means this is independent of path. Okay. Therefore, this force also conservative. So like this, we can verify a given force is conservative or non-conservative. Okay. I hope you got clarity. Let us see problems basing on this. See here what is given. A block of mass 1 kg is moving from origin to 2, 4 under action of many forces. Find work done by the force F bar equal to 3I cap plus 4J cap if the block is taken along the path y equal to 2x, next y equal to x square. So just now we have discussed that constant force is conservative force, right? So to make this calculation, F bar dot ds bar, it becomes 3 dx plus 4 dy, right? So we do not require these equations. Okay. So directly what we can write? See here. Given force equal to constant force given 3I cap plus 4J cap. So since force is a constant, directly we can write W equal to F bar dot S bar, right? And here F bar given 3I cap plus 4J cap. S bar taken from origin to 2 comma 4. So S bar is 2 I cap plus 4 J cap, right? See, to make this a calculation F bar or S bar, we don't require any path equation. Yes or no? F bar given, S bar given. We do not require any path equation. It is a conservative force. So we get answer directly. Okay, right. Let us see next problem. This is now previous I had a question given, just slightly modified. So everything is same. Only change is we are given here path equation. Y equal to x square, y equal to x. Okay. So equation question is same. Only changes I have given here path equations. Y equal to x square and y equal to x. Right. Let us see now where change comes. So force is given F bar equal to y cap plus x j cap. Okay. Work done is equal to integral F bar dot ds bar. So since the force is variable, we have to take integration. Now integral y cap plus x j cap dot dx I cap plus dy j cap. From this what we get? It is y dx plus x dy. So after getting here, you can see, or this can be taken directly as integration of d of xy, means if you know this mathematics, okay, then this becomes directly d of xy, which is equal to xy. Final answer, right? That is the final answer. But here what I am saying is, if you are not knowing this result, if you are not knowing this result, then how to simplify this? Okay. So here, if I divide this into integral y dx plus integral x dy. See, we cannot take y out of integration because y is variable. We cannot take x out of integration because x also variable, right? That means making this a calculation is not possible if you are not knowing this result, right? The next possibility is converting this equation into single variable. So here y is variable, x also variable. We want to convert into single variable, right? Then we require connection between x and y. Okay. So here we are given equations y equal to x path equation. Next y equal to x square, right? Like this. One thing you have to understand, this can be directly taken as d of xy. That means we won't require any path equation. So this given force is conservative. That is clear. But why I'm taking a path equation means if you are not knowing this result, writing this as d of xy, then take any equation of your choice, okay, to convert into single variable. Suppose I am taking y equal to x. So now from this what I can say? In the place of y, I can write x. So x dx plus x as usual. In the place of dy, from this equation I am writing, from this equation dy equal to dx. So in the place of dy, I'm writing dx. So it is equal to integration of 2x dx. Okay. Then see what figured answer here. It is equal to x square, right? Now limits. Limits are given here. Origin to a comma a, right? In the question. If you see here answer a square, right? In this one. Now this also a square. Okay. So I have taken here force how much? Y cap plus xj cap. I think in the question given minus k into, right? In that case, see what happens. We get here minus k a square. Minus k a square. Okay. So we got same answer. Okay. Into I'm writing here minus k into minus k. In the question given minus k into minus k. So take minus k here also. In every equation, take minus k. Here also minus k you can take. Right. So you have to understand that you can take any path equation to convert this into single variable. Okay. So this is a conservative force. That's why we don't require any path equation. Right. Let us see next one. Repeat the above problem by taking force F bar equal to minus k into 2y I cap plus 3x j cap. Now here we should be very careful. Given now 2y I cap plus 3x j cap. See what is given here. F bar equal to minus k into 2y I cap plus 3x j cap. Right? So work done equal to minus k take outside. Remaining is integration of 2y I cap plus 3x j cap dot dx I cap plus dy j cap. Okay. Now simplify this minus k into 2y dx. Okay. Plus 3x dy. Right. Remember, this cannot be taken as integration of d of something. Okay. This cannot be taken as d of something. Okay. That means this is not a conservative force. So here what is I'm saying is one more conclusion that if we can write this one as d of something, then that force is a conservative. So this cannot be taken in that form. Then in this we require path equation to solve the problem. If path equation is not given, we cannot solve the problem. So if you take path equation y equal to x, in the place of dy, we can write dx. Then see what is answer. Minus k into integral 2x dx plus 3x dy. Okay, sorry. This also dx only. It is dx. So 2x dx, 3x dx. Total is now 5x dx. So minus k into 5 is there. 5x dx. It becomes now x square by 2. Okay. Now do one thing. Take the next path equation y equal to x square. Check the answer once, okay? Same or different. Now I'm taking the path equation. Y equal to x square. From this, dy equal to 2x into dx. Now substitute there. Suppose equation 1. From equation 1, w equal to, take minus k outside. Integration of, in the place of y, taking it is x square. So 2x square dx. Okay. Plus 3x in the place of dy we can write 2x into dx. Okay. Now this is minus k. This becomes how much? 2x square. This is now 6x square. It is 7x square. Take 7 outside. X square dx. X cube by 3. Suppose you are given limits. Let us say taken from origin to 1 comma 1. Okay. To make calculation simple, I am taking 1 comma 1. Then in this, see what we get answer. If you take limits, minus 5k by 2 x square, that is 1. Okay. Answer is minus 5k by 2. Now in this, see what is the answer. If I am taking limits, minus 7k by 3. Okay. So here, finally work done depends on the path. Okay. So here what I am saying is, equation 1 cannot be written as d of something. That's why that force is not conservative. So yeah, I'm repeating two conclusions here. One conclusion, if we can calculate this without the help of any other equation, then that force is conservative. Second point, if we can write this one like d of something, then also that force is conservative. Right? Let us see next problem. This is a very simple question given in previous IIT. See once. If W1, W2, W3 represent the work done in moving a particle from A to B along three different paths, 1, 2, and 3 respectively, as shown in the figure, as shown in the gravitational field of a point mass m. Find the correct relation among W1, W2, and W3. This is asked in 2003 for 2 marks. We have learned that gravitational force is conservative force. That means work is path independent. Therefore, W1 equal to W2 equal to W3. Okay. Path 1, path 2, path 3, irrespective of the path, work done is same because gravitational force is a conservative force. Right? So this is regarding conservative force.